So the question we're answering is, a projectile is shot upward from the surface of the Earth with an initial velocity of 84 meters per second. The first part of it is asking us to find the position for this projectile. So we start with S of t, which is equal to half of g of t squared, where g is gravity, plus v subscript o of t, where v subscript o is equal to velocity, and then plus s of o, or s subscript o, which is equal to the position that it took off from. So g is just a constant that's given to us, depending on whether or not we are using feet or meters, which in our case it says meters, so this is the one that we're going to be using. And then our initial velocity is 84, and then because we weren't given a position from where we started, this is just going to equal 0. So we're going to start out by writing it down as S of t is equal to 1/2 of negative 9.8 t squared plus the initial velocity times t plus position, which is just 0. So this is going to give us negative 4.9 t squared plus 84 t. And that's going to be your position function. The second question asks us to find the average velocity of the projectile from 3 seconds to 5 seconds. So the way we're going to do this is change in distance, which is shown by s of the numbers that we were given were 5 and 3, so s of 5 minus s of 3 over the change in time, which is 5 minus 3. So when we write this out, we are going to end up with negative 4.9 times 5 squared plus 84 times 5 minus negative 4.9 times 3 squared plus 84 times 3 all over change in time, which is 2. So this is going to give us 297.5 minus 207.9 all over 2, which is equal to 89.6 over 2. So our answer is going to be equal to 44.8 meters per second. So the third question asks us to find the velocity of the projectile at 3 seconds. So considering we're only given at exactly 3 seconds, that means that they're looking for instantaneous velocity. So in order to find that one, we need to find just the plain velocity. Now, velocity, or v of t, is equal to the derivative of s of t. So we know that s of t is equal to negative 4.9 t squared plus 84t. So the derivative of s of t is equal to negative 9.8 t plus 84. So if we evaluate this at the point 3, you have s prime of 3 is equal to negative 9.8 times 3 plus 84. This is going to give us 54.6 meters per second. And this is your instantaneous velocity. And then the last part of the question tells us to find the acceleration of the projectile at 5 seconds. Now what we need to remember is that which velocity is simply the derivative of s of t. Acceleration is the second derivative of s of t. So a of t is equal to s double prime of t. So we already know that s prime of t is equal to negative 9.8 t plus 84. So when we take the derivative of our derivative, s prime of t is equal to just negative 9.8. And this will be meters per second. So no matter what numbers you're given, no matter what t is, your acceleration is always going to be either negative 9.8, or if you're dealing with feet, negative 32 feet per second. And there you go.